Hey students, today we will start a new topic which is heat capacity. And it is a very important topic in the section of heat and gases. In this video, we will define heat capacity as C equals to Q over delta T. And this Q represents the heat. And to align with the textbook, we would use E as the symbol for energy because you know that heat is energy. And this time in this notes, we will use E as the symbol for energy. So talking about heat capacity, let's think about a question. When we want to increase the temperature of something, what should we do? Yes, we would heat it. That means to provide energy to that object. And here, heat capacity is talking about the energy required to raise the temperature of a body by 1 degree Celsius. That means how much energy is required to increase the temperature of a body by 1 degree Celsius. And when we heat a body, that body would gain energy. That means the energy would increase, and that energy absorbed would turn into the kinetic energy Ke of the molecules. And in chapter 1, you have learned that the average kinetic energy is indicated by the temperature. So when the body absorbs energy, then the temperature will be increased. We can write down temperature here. Temperature rises. So let me give you an example. 800 joule of energy. 800 joule is required to raise the temperature of a glass of water by 1 degree Celsius. Then what's the heat capacity of the glass of water? Which is actually exactly 800 joule per degree Celsius. Because you know that heat capacity here, heat capacity is the energy required to raise the temperature of a body by 1 degree Celsius. So if 800 joule is required to increase its temperature by 1 degree Celsius, then what's the heat capacity? It's 800. And this time, what about the energy required to lower its temperature by 1 degree Celsius? It's actually the same. No matter it's lower or raise the temperature by 1 degree Celsius, it's the same. So it's also 800 joule. That means it's not just raise the temperature, it's about changing its temperature by 1 degree Celsius, and that energy is the heat capacity that we are talking about. Let me give you more numbers. If 800 joule is supplied to the glass of water and its temperature change from 20 degrees Celsius to 21 degrees Celsius, which means that the change in temperature is 1 degree Celsius. Then if 800 joule is required, then we can know that the heat capacity for this glass of water is 800 joule per degree Celsius. Let's think more. So if this time we want to increase the temperature of the glass of water from 21 degrees Celsius to 22 degrees Celsius, how much energy is required? Actually, it's just the same. It's also 800 joule. Because to change it from 20 to 21, or to change it from 21 to 22 degrees Celsius, or 22 to 23 degrees Celsius, or 23 to 24 degrees Celsius, is the same. If the change in temperature is 1 degree Celsius, then it requires the same amount of energy, which is also 800 joule for this glass of water. So, of course, if we want to change more, that means if we want to, let's say if we want to increase its temperature by 10 degrees Celsius, then of course the energy required would be more than that to change its temperature by 1 degree Celsius, right? in a greater change in temperature require a greater amount of energy. So here, the relation between C, the heat capacity, and the energy E, and also the change in temperature, delta T, would be E equals to C delta T. And delta T here refers to this meaning, change in. So here delta T means change in T, which is change in the temperature. So this energy required to heat that body by up by 1 degree Celsius would be C times 1. So here, to raise it up by T degrees Celsius, you don't know the T, let's say it's unknown, then it's E equals to C delta T. So a greater change in temperature, then greater amounts of energy is required. How about this time we want to calculate the heat capacity? Then it's easy, we just change subject. We just put this delta T to the left hand side, which the C would be equal to E over delta T, the energy over the change in temperature. And the unit for heat capacity is joule per degree Celsius. If you wonder why, it's because the the units for energy is joule, and the units for change in temperature is degree Celsius. So the unit for heat capacity is joule over degree Celsius, which is the same, joule per degree Celsius. Okay, let's go to page 2. Let's look at this example of glass and pool. We are trying to compare a glass of water and a pool of water, which is a swimming pool. For a glass of water, it requires 1 kilojoule to raise its temperature by 1 degree Celsius. Then, if we want to calculate the heat capacity here, which is E over delta T. So E here is not 1, it's 1,000 because it's 1 kilojoule. So it's 1,000 over 1. And this time if we use index here to represent it, then it's 10 to the power of 3 joule per degree Celsius. Remember this units, don't just write down joule. And for a pool of water, which requires a lot more energy to increase its temperature by 1 degree Celsius, then this time the energy here would be 10 to the power of 7. Also, we need to change it times 1,000 because it's 1 kilojoule. And the delta T is the same, is also 1 degree Celsius. So here, because actually 1,000 is 10 to the power of 3, so we will get this answer of 10 to the power of 10 joule per degree Celsius. This value here for a pool of water is 10 million times bigger than this value. And it makes sense because obviously we need more energy to change the temperature of such large volume of water compared with just a glass of water. And further thinking, we try to think more. If 5 kilojoule of energy is supplied to the glass of water at 25 degrees Celsius, what would be the final temperature? That means if we supply this amount of energy to the glass of water, how will it change? Refer to here, a glass of water requires 1 kilojoule to change its temperature by 1 degree Celsius. So what if we supply 5 kilojoule? It's the 5 times of the energy state here, right? So the temperature change which would also be 5 times greater than this one. So here, if we supply 5 kilojoule, then the temperature will change by 5 degrees Celsius. So that's the final temperature here would be 30 degrees Celsius. 1 kilojoule, then change in temperature is 1 degree Celsius. So 5 kilojoule the change in temperature is 5 degrees Celsius. So this is 25 plus 5, which is 30 degrees Celsius. Another question. A glass of water and a pool of water, they require different amounts of energy to raise it by 1 degree Celsius. And why? Yes, they are both water, but what is different? You may want to say the size or the volume, but I will give you this term, which is mass, because they have different masses. So they need different amounts of energy to change its temperature. Okay, let's look at example 1. We really need to calculate here. This example is about a pot of tea is supplied with 30 kilojoule of heat, which means 30 kilojoule of energy, and the heat capacity of the tea is 7,500 joule per degree Celsius. So we got E here, we got C here, and what do we need to find? The increase in temperature, which is the change in temperature. So it's delta T, change in temperature. And we can just apply the formula we have just learned to solve this problem. E equals to C delta T. You have the E and you have the C, so you just need to substitute the values to the equation, then you will get this delta T. And please try it by yourself. And for part B, this time we need to determine the increase in the internal energy of the tea in kilojoule when its temperature rises from 25 degrees Celsius to 80 degrees Celsius. So this time we need to find the E here, and we have the C, which doesn't change, right? It doesn't change because it's the same pot of tea. And we also have the delta T this time. We just need to calculate it by using the same formula for part B. So let's also do it by yourself. And the last example is also about heat capacity. But this time you can see that we use this table to compare something. And this time, the mass is the same. And the energy supplied is not the same, but the temperature change is also the same. So here, by relating the relation of E, C, and delta T, you can see that here the mass is the same, right? And E here is different, but delta T here is the same. So you can guess that the C of these two blocks would be different. And I would like you to try to calculate the heat capacity here and also think about they're having the same mass, but why they require different amounts of energy to raise it by 1 degree Celsius. So that's all for this video.